so today we are going to graph and write equations of ellipses. The definition of ellipse is it's the set of all points such that the sum of the distances to the foci is constant. So no matter where I go on the ellipse, if I draw a line to each of the focuses or foci, those two lengths are going to add up to the same number no matter where I go on the ellipse. It'll always add up to the same thing. So like if you wanted to draw an ellipse, you could take a piece of string, that would be that constant distance or the constant sum. You could tack it in two different places and then take a pencil and stretch the string, and you'd be able to draw an ellipse with a string and two thumbtacks and a pencil. So we don't have time to do that though. But that's the definition. Okay. All right. So an ellipse can be either horizontal or vertical. If it's horizontal, if the equation is x squared over v squared plus y squared over c squared equals 1. If it's vertical, then the v squared is under the y. So x squared over c squared, y squared over v squared equals 1. And so I'm using v to represent the distance from the center to the vertex. So that's why I chose V for vertex. And C is the distance from the center to the co-vertex. That's why I use the letter C for co-vertex. And we haven't talked about it yet, but F is going to be the distance from the center to the focus. And it's the letter F. So what that looks like is on my horizontal ellipse, the vertices are on the x-axis. On my vertical one, they're on the y-axis. So the V is just the distance from the origin to that vertex, okay? I'm not going to leave that there, though, because my drawing is going to get too crowded if I leave those all on there. All right, then the co-vertices are the other points that are on the other side. So that's a co-vertex, and that's a co-vertex. And on my vertical one, they would be right there. The focus is on the same axis as the vertices. So my foci would be here on the horizontal one, or here on the vertical one. And the last thing I need to tell you about are the major axis and the minor axis. So the major axis is going from vertex to vertex. And so there it is on that one. And then the minor axis goes, I can't say it today, is going from co-vertex to co-vertex. It's the shorter one, basically. Okay. So there's a relationship that exists between the vertices, co-vertices, and foci. It turns out that the distance to the focus squared is equal to the distance to the vertex squared minus the distance to the co-vertex squared. And it's actually based on the Pythagorean theorem that I could draw a triangle inside of there that, like here, I have a right triangle, right? And so it turns out this distance ends up being the same as the distance to my vertex. And then that's my distance to my focus, and that's my distance to my co-vertices. So f squared plus c squared is v squared. But we know what the v squared and the c squared are from the equation. So we're usually solving for f, and so we just put f squared equals v squared minus c squared. But it's all based on the Pythagorean theorem. All right, so now let's use all this information to do a problem. For example 1, we're going to graph the equation 4x squared plus 25y squared equals 100, and then we're going to identify the vertices, co-vertices, and foci of the ellipse. So the first thing I notice is that my equation is not in standard form. In standard form, what was on the right side of our equation? What did you guys just write in your notes? What should it equal?
1.
1. So that means I have to divide everything by 100 to make it equal to 1. And then you just reduce the fractions. So 4 goes into 100 25 times. 25 goes into 100 4 times. And then, of course, this becomes 1. So now I've got x squared over 25 plus y squared over 4 equals 1. And now I've got it in standard form. So is this one going to be horizontal or vertical? Where's the bigger number? The bigger number is under the x squared, so it's horizontal, exactly. So, and if you're not sure, just take the square root and graph it, and you'll see. So, the square root of 25 is 5, and the square root of 4 is 2. So my vertices are going to be at plus or minus 5 on the x-axis, and my co-vertices are going to be at plus or minus 2 on the y-axis. And then just do the best you can to draw something that looks kind of like an ellipse. So now all that's left for me to do is find out where my foci are at. So I can use that relationship that f squared is v squared minus c squared. And so v squared was 25, c squared was 4. 25 minus 4 is 21. So the distance to the focus is just going to be the square root of 21. And that's approximately 4.5. So from the 0, I'm going to go plus or minus the square root of 21, so about 4.5. So that's where my foci would be. So just listing all of them then. The vertices are at negative 5, 0 and positive 5, 0. My co-vertices were at 0, negative 2 and 0, positive 2. And then my foci was at negative root 21, 0 and positive root 21, 0. Okay, so now I've got one for you guys to do on your whiteboards. 25x squared plus 9y squared equals 225. Before you go to all the trouble to graph it, show me your equation so I know you're doing it right, okay? All right, so are we all coming up with x squared over 9 plus y squared over 25 equals 1? Okay, so now my larger number is under the y squared, and so is this one horizontal or vertical? This one is vertical. Okay, so that means that that is my vertex and this is my co-vertex. Okay? Okay, so that's what we ended up with for our graph. The vertices are at 0, -5, and 0, +5. Our co-vertices are at -3, 0, and +3, 0. And the foci were at 0, -4, and 0, +4. Questions on that? All right. So now let's write some equations. We're going to write the equation of an ellipse that has a vertex at 0, 4, a co-vertex at -3, 0, and the center at 0, 0. So today, all the ones we're doing, the center is at 0, 0. We won't worry about moving them until next week. We'll translate them next week. But right now, for today and for tonight, when you do your homework, we're just doing the center at 0, 0. So I notice that my vertex is at 0, 4. So which axis is that going to be on? That's on the y-axis, isn't it? So that means that this is one that's vertical, yes. And my co-vertex over here is on the x-axis. So if you need to, you can always draw yourself a little graph to visualize it. I mean, if you have a hard time keeping that straight and you want to draw yourself a little picture, you can do that too. Okay, oh yeah, that's that, that's that. It means it's this distance is 4, this distance is 3. So that's going to be my v, and that's going to be my c. So x squared is over the -3 squared, which is 9, and y squared is over the 4 squared, which is 16, equals 1. That's it. There's your equation. This one doesn't ask you to find the focus, so you don't have to. But if I wanted to, I could. Okay? Questions? These are probably the easiest ones to write, is when they give you the vertex and the co-vertex. I'll let you guys practice on this one. All right, so this time it was on the x-axis. And so we ended up with x squared over 49 squared plus y squared over, 49, not 49 squared, plus y squared over 2 squared, which is 4, equals 1. I think all of you guys had that. All right, so now let's do one where I give you a vertex and a focus. So the vertex is going to be at -8, 0, and the focus is at 4, 0. And again, we're dealing with the center at 0, 0. All right, so, oops, didn't mean to do that. All right, so this time I see that my vertex is at -8. It's on the x-axis. So I know part of my equation is x squared over 64. But what I don't know is what my y squared is over, because I don't have the co-vertice. And so I'm going to use that relationship, s squared equals v squared minus c squared, to figure out where the distance to my co-vertice. So f we get from over here is 4, so that 4 squared is 16, and then 8 squared is 64, and so I subtract 16 and I get that c squared is equal to 48, and so that's what goes under my y squared. Okay. Questions on what I did there? All right, here's one for you guys. All All right, so for that one, we ended up finding out that the distance to the co-vertex squared was 16. So x squared over 25 plus y squared over 16 equals 1. All right, so let me do one more example for you guys, and this time I'm going to give you the co-vertex and the focus, and that way you will have seen one of each type. So this will be example 4 in your notes. All right, so again, we're going to stick with the center at 0, 0. The co-vertex is going to be at 12, 0, and the focus is at 0, negative 5. And so because my focus is on the y-axis, I know that this one has to be vertical. So this is going to be what's under my my x squared right here. So I've got x squared over 144 plus y squared over something is going to equal 1. And then f squared equals v squared minus c squared. So 25 equals v squared minus 144. And so if I add 144 to both sides, I get that my v squared is 169, so that's what goes under the y squared. Okay, you guys want to try one of those on your whiteboard? Okay. All right. So I'm going to give you one with a little bit harder numbers so you can get practice. All right, so we're going to have the co-vertex at negative 5 root 7, 0, and the focus at 0, 15. All right, so when you solved that one, you ended up with x squared over 175 plus y squared over 400 equals 1. Do you guys want another one to practice? No? It's okay.
Yeah.
All right, so you guys are feeling comfortable with these?
Yeah.
So everybody's going to do all their homework tonight?
Yeah.
Woohoo! Awesome. All right. All right, that's it for today then.